So look at this question number 6. If the distance between two masses be increased by a factor of 6, means suppose there are two masses, M1 and M2. Now suppose there are two masses, M1 and M2, right? Okay. And there is a distance between them, which is D, right? The force of attraction will be, according to the universal law, F is equal to G M1 M2 upon D square, right? Okay. Now what is given here in this question? That distance between two masses be increased by a factor of 6, right? Means this D is increased by 6. So now they are far apart, right? M1, M2. And now it will become 6 times, 6 into D, right? Now you have to tell that by what factor would the mass of one of them have to be altered to maintain the same gravitational force, right? So since, as we know that, just look at the formula, as we know that F is inversely proportional to the square of the distance between the two masses, right? That means if we increase the distance, force between the two masses will decrease. This force of mutual attraction will decrease. Are you getting my point, right? But here they are saying that to maintain the same force means we need to keep this force same, right? This force should be same. Then we need to increase either M1 or M2 or both, right? Okay, because F is directly proportional to the product of the masses of the two bodies. Are you getting my point? Right. So if we increase the mass of any one of the object or both the object, means M1 and M2 is increased, then only the force will remain same, right? So in this question, what they have asked, like they have asked like one of them is altered, means one object mass is actually increasing. Now you have to tell how much we need to increase that mass, increase the mass of that one object so that your F will remain same. Is that clear? You getting my point? Yes or no? So this you have to tell here, right? So you have to tell like how, by which factor you have to, like how much you have to increase the weight of one body so that F will remain same. Is that clear? Getting it? So now what we have to do? Okay. So now, as we know, F is equal to G M1 into M2 upon D square, right? Or R square. That means what? Force is inversely proportional to the square of the distance between the two masses, right? Now, according to the question, distance between the two masses is increased, right? So now D dash, the new distance between the two masses, right? Suppose this is D, M1, M2, and this is D. Now this is increased, and the new distance between the two masses is suppose D dash, right? And this D dash is 6 times of D, right? Okay, means अगर ये पहले 1 meter था, तो ये अब 6 meter. This is the meter, 6 times of D. Getting that? Okay, so D dash will be equal to 6 into D, right? So if we put this value, F is equal to G, right? M1, M2 upon 6D whole square. So instead of D square, we need to write 6D whole square. So that will become G M1, M2 upon 36D square, right? Is that clear? Okay. That means what we need to do, like what will be the new force? What will be the new force? It is decreased by 36. Yes or no? Okay. Suppose this is F dash. Okay. And this whole thing is your F according to this, right? From 1, right? This whole thing is F, right? So can I write that F dash will be equal to F upon 36, right? That means force will decrease by 36, right? Okay. It will become 1/36th time of the force which was there earlier, right? So what we need to do? So if we need to multiply any one of the mass will by 36 means we have to increase any one of the masses by 36 times so that F will remain same. Are you getting my point? Right? Okay. So write down to maintain same force, one of the mass is to be increased by 36 times. So any of the mass is increased by 36 times, then what will happen? This 36 will cancel and you will get the same force again, right? So if we are decreasing, if we are increasing one, we have to, if you are increasing one, you have to increasing the mass, right? If you are increasing the distance between the two objects, then you have to increase the mass to make that, to keep that force of attraction same. Are you getting my point? Yes, sir. So please write down. Right. So what is given here? Calculate the acceleration due to gravity on the surface of a satellite having mass 7.4 into 10 power 22 kg and radius 1.74 into 10 power 6 centimeter. And take G is given 6.7 into 10 to the power minus 11 Newton meter square kg square. Right. Okay. So as we know that acceleration due to gravity is, so first write down acceleration due to gravity. How to find acceleration due to gravity? Using this formula, you can find out the acceleration due to gravity of any celestial body. If you know its mass, if you know its radius, right? Any satellite, any body, right? You can find it. So this is G, capital G, M upon R square, right? Where M is the mass of the body, R is the radius of the body, right? And G is the gravitation, capital G is the gravitational constant. So write down what is given here. Capital G value is already given 6.7 into 10 power minus 11 Newton meter square per kg square. Mass of satellite, it is given 7.4 into 10 to the power 22 kg. Okay. R, radius of the satellite, 1.74 into 10 to the power 6 centimeter. This is in centimeter. So we need to convert this into meter. So if we divide this with 100, right, we can convert it into meter, right? Okay. Getting that? So we have to divide with 100. So this will be equal to 1.74 into 10 to the power 4, right? 6 ki jagah 4 raha, right? Meters. So we have converted the radius from centimeter to meter, right? Now we can put the values. So always remember, whenever you are putting the values within the formula, always check their SI units, right? If you do not check and you put them as it is, then your answer will be wrong if the unit is not correct, right? So they should be in their SI unit. So now find the value of G. Capital G is 6.7. 6.7 into 10 to the power minus 11 into capital M is 7.4 into 10 to the power 22 mass of the satellite upon R square. R is 1.74 into 10 to the power 4. Right? We will put this now. Whole square. Okay? Is that clear? Now calculate this. So to solve this, first we will separate the decimal numbers. Right? Okay. 6.7 and 7.4 in the numerator. Right? 10 to the power minus 11 and 10 to the power 22, right? We have written them together. Now, if you look at the denominator, we have 1.74 into 10 to the power 4 whole square. This is a whole square. Means there is a square of 1.74 into there is a square of 10 to the power 4 also, right? Okay. We are separating this, right? Okay, by the exponential law. Now, 6.7 into 7.4 upon 1.74 into 1.74. Can I write like this? Because this is the square, right? I have written them twice. Into 10 to the power minus 11 into 10 to the power 22. Now, by the exponential law, whenever you have power to the power form, the power get multiplied, right? So if you have the form like a to the power m to the power n, this is equal to a to the power m into n. This you have already studied, right? Okay, so using this law, we need to multiply this, right? 4 and 2 we need to multiply, yes or no? Getting it? So 4 into 2 will become 10 to the power 8, right? It will become 10 to the power 8. Getting that? Now, we will solve these separately, right? 6.7, 7.4, 1.74, 1.74, right? How to do this? What do you need to do? Multiply this, right? Okay, 6.7 and 7.4. When you multiply this, what you will get? Whenever you are multiplying two decimal numbers, just forget their decimal points. Okay, just multiply them as it is, right? As you are multiplying the numbers, right? So multiply 67 and 74. ये तो करना आता है, right? 67 and 74. So 67 into 74 is 4,958. Right? Now put the decimal back. एक decimal point ये है, एक ये है. In multiplication, the decimal points get added. Look at the screen. The decimal point get added, right? So 1 and 1 will become 2. So we will put the decimal point here after 2 places. Right? Okay. Now we will multiply 1.74 and 1.74. Again, multiply them without taking the decimal point. Just find out what is the square of 174. Right? So 174 is 30,276. Right? Okay. Now put the decimal back. So again, look at here. 2 decimal places here, 2 decimal places here. Total will become 4. So you have to put the point after 4 decimal places around 3.0276. Right? So this is how we multiply the decimal numbers. Getting it? Now you can find out it approximately also, right? So first let's solve this one, right? This part. Now look at it. 10 to the power minus 11, 10 to the power 22. So if you remember, we have the exponential law. We have the exponential laws. Proceed to the screen. A to the power m into a to the power n. This is equal to a to the power m plus n. So when you have two exponential number having same base and they are in multiplication, their power get added. Okay? And when you have two exponential number in division having the same base, their power gets subtracted. These exponential laws you have already done, right? So we will apply this here. Now 10 to the power minus 11 and 10 to the power 22 having the same base. They are in multiplication, so power will get added. So when you add them, minus 11 plus 22, you have to do like this. Getting it? Okay. Upon 10 to the power.
33.
No, this is not 33. Minus 11 plus 22 is 11. Right? Because we have minus sign here.
तो
Right?
ग्रेटर का साइन तो प्लस का है.
So it will be 11. 10 to the power 11. Right? Now look at here. 49.58 is approximately what you can take it as. 50 you can take approximately 49.58, right? So we are finding the approximate value, right? Divided by 3.02 can be taken as 3. 3.02 is approximately 3, right? Into, now here 10 to the power minus 11 plus 2 is 10 to the power 11, right? Minus 11 plus 22 upon 10 to the power 8. Now 50 divided by 3 is 150. 50 divided by 3 is 20, 25 approximately. 16.6 approximately, right? Okay. Now this will be 10 to the power 11 minus 8, right? Because in division, the power gets subtracted. So it will become 11 minus 8. Getting that? Okay. So what is your G, the value of G? It is 16.6 into 10 to the power 3, right? 11 minus 8 is 3. Are you getting that? So G is approximately 16.6 into 10 to the power 3 meter per second. Are you getting that? So this is how we will get. Getting that?